Well, now I'll talk about the average value of a function. First, what exactly does that mean? Well, in general, an average is found by adding up the values and dividing by the number of values. But over an interval, there's infinitely many numbers. So if I want to look at this graph and find the average, there are infinitely many numbers between these two spaces that I would have to add up. So how can I do that? Well, our first guess might be to pick some test values throughout here and find their average. And that is a great first step. And then as we do that, we can do more and more test values and take more and more and more and more and more so that we have a lot of test values. So now the number of things there are is the length of the interval divided by the width of the interval. And that now tells us exactly how many things I have. So I know what to divide by. So as I'm adding all of these things up, I'll represent these as f of xk star to represent my test values. When I divide by a fraction, I multiply by the reciprocal. Sorry, this is b minus a, not a minus b. And now I have this function. But like I said, we keep wanting to take more and more and more, so we're going to try to take the limit of this thing as n goes to infinity. And when we do, the limit of an infinite sum like this is the integral from a to b of f of x dx. We do still have this 1 over b minus a out front. So essentially, to find the average value, we're going to integrate the function and divide by the width of the interval. And in general, the average value of a function is the height of the rectangle that has a base from a to b that has the same net area as the region bounded by f. So if we take this area underneath our curve f of x, and we turn it into a rectangle with the same area, the height of that rectangle is our average value. So now let's look at some examples. For our first example, we want to find the average value of the function absolute value of x minus 3 over the interval negative 2 to 5. So our formula says we need to do 1 over the length of the interval, which will be 5 minus negative 2. We then do the integral from negative 2 to 5 of the absolute value of x minus 3. Well, in order to actually take the integral of an absolute value, we kind of have to think about what's going on. We know that from negative 2 to 0, the absolute value of x, well, we need to change the sign because we'll be inputting a negative number. So negative x minus 3 dx. Between 0 and 5, the absolute value of a positive number is just itself, so now we have just x minus 3. I now have 1 over 7 times, add 1 to the exponent and divide by 2, and then the same thing here, between negative 2 and 0, plus 1 over 7. Once again, add 1 to the exponent and divide by that number, minus 3x, between 0 and 5. Evaluating this, the top limit is going to give me 0 minus negative 1/2 times negative 2 squared minus 3 times negative 2. And then the second one will stick in 5, so 1/2 times 5 squared minus 3 times 5 minus the lower bound, which is just 0. And whenever we work all of this out, we get negative 13 over 14. This one looks a little bit simpler. We're just going to take the average value of x squared over the interval 0 to 3. We have 1 over 3 minus 0 times the integral from 0 to 3 of x cubed, or x squared. So this is 1/3. We add 1 to the exponent and divide by that number, between 0 and 3. I now have 1 over 9 times 3 cubed minus 0, which is just 3. So we have our average value of 3. Let's now talk about the mean value theorem, which is very related to this average value. So first, we need our function f to be continuous. Then essentially what it says is there is some point. So there is a c in our interval a to b such that this average value is equal to f of c. So essentially we have to actually reach the average value at some point. So let's look at this. We did this example earlier in the video where we used the function absolute value of x minus 3 on the interval -2 to 5 and found the average value to be -13/14. What the mean value theorem says is that if I set my function equal to my value, there will be some solution in the interval -2 to 5. If I add 3 to both sides here, I get 29/14. And using absolute values, x is 29/14 or -29/14. Well, 29/14 is roughly 2.07. So this is in my interval, whereas -2.07 is just outside. But we did satisfy the mean value theorem. We knew the average value, and we found a point where the function was equal to the value. We also found that the average value of x squared over the interval 0 to 3 was 3. So my mean value theorem says there is some point where x is equal, or f of x is equal to 3. And we can see that this is the square root of 3. It's also equal at negative square root of 3, but that's not actually in our interval, so we don't care about that one. We just care about square root of 3.